When light is transmitted through an interface from one medium to another, the light will change speeds, and that will cause it to change direction. Again, we're going to draw in a normal, which is perpendicular to the surface of the interface. And you can see that the light changed direction, which we would call refraction. The incident ray makes an angle with the normal, and again we call that the angle of incidence. And the refracted ray makes a different angle with the normal, and we call that the angle of refraction. We'll call that theta prime. And we have two indices of refraction again, n here and n prime here. And Snell's law states that the angles of incidence and refraction and the index of refraction of the first medium and the second medium are related, and you can use the equation n times the sine of theta 1 that would be the theta I equals n times the sine of theta prime. I'm sorry, it would be n prime times the sine of theta prime. And usually when you see this equation written out, you'll just see not written as theta I, but just plain theta. So you can see how if you know the index of refraction of each material, and if you know the angle of incidence, then you can use those to determine the angle of refraction. For this example, we'll say that a light ray strikes a air-water interface. We know air has an index of refraction of 1, water is 1.33. So this is our n, this is our n prime. And if the incident angle is 30 degrees, what is the angle of refraction? So we use our formula. N times sine of theta equals n prime sine of theta prime. So here we have 1 times the sine of 30 degrees equals 1.33 times the sine of theta prime. And if you plug your numbers into the formula, solve for theta prime, you find that the angle of refraction is equal to 22.03 degrees. And you can see demonstrated here a general rule that I want you all to remember, which is that if the incident ray is in a lower index of refraction and the refracted ray is in the higher index of refraction, then the ray is bent toward the normal. So you can see that this ray was headed towards this direction, but instead was bent toward the normal. And that's going to happen anytime that you have the incident ray in the lower index of refraction.